shuttle that they're very high-tech, very high-quality cameras. Many of them are off-the-shelf cameras, but they're retrofitted with more advanced chips inside of them and also image intensifiers and special filters. So the camera that we just did the test on was a very high-tech camera, but certainly you can imagine that what they're using on the space shuttle is even better. So why, in this scene that we just did, do a pair of keys appear so crisp and so sharp and in focus, at the same time we're focused on a very, very distant object? It seems to defy the explanations and reasoning Dr. Knuth gave as to what we were seeing on the tape. James Oberg came up with excuses about what we were seeing. He couldn't acknowledge that the objects were going behind the tether. He just ignored the facts, the simple facts. He tried to say that what we were seeing was an optical illusion produced by the CCD in the video camera. He's trying to say that as these objects came near to the camera and they got close, they produced this fuzzy orb called an airy disk. When an object gets too close to a video camera or to a lens in a 35mm camera, for example, it just basically produces a very fuzzy and very soft light. It's very translucent and in some cases barely even detectable. They basically look like this. Sometimes they have a little black hole in the middle, just like our alleged UFOs do, and you get a very fuzzy kind of cloudy light around them. But all of the light is out of focus. So I can understand how he could make an assumption like that. But also with an airy disk phenomenon, you would also never get a clear, very distinct line. When we see the UFOs going behind the tether, the line and the crispness on the line on the tether is so straight and so perfect, suggesting again that everything is in focus. When I demonstrated the test on the camera earlier, where we passed a set of keys very close, within 4 or 5 inches of the camera, while the camera was focused at an object far in the distance, we noticed that the keys were very much in focus. There was no airy disk around the keys. We didn't get an effect like this. We had keys that were perfectly in focus while the tree in the background was also in focus. So what was James Oberg trying to tell me? In the year 2000, I did a lot of investigations with different scientists all over the world. I got contacted by an astronomer, actually the head astronomer of the Canberra Observatory in Australia, Claire Williams. She had already seen the tether footage. She had already seen the STS-75 tether footage. She didn't have a very good copy of it, and we got into a furious debate about airy disks. She felt that what we were seeing on the tape in the tether were just airy disks. Airy disks are when you have like a star or a pinpoint light source, and the camera lens goes way out of focus. It produces something very similar to the UFOs that we've seen on the tape. You see a very soft black hole in the middle and a very translucent disk around the pinpoint light source. So what happens is the light becomes so diffused in the lens because it's so out of focus that we get this phenomenon called airy disk. And when many people would look at this, they would say, oh, that looks a lot like the UFOs we've seen on the tape. And I understand how Claire Williams came to these conclusions. But there's no way that an airy disk could appear to pass behind. And remember, in the tether incident, we have the tether, which is over 77 to 100 miles away, and we saw the disk going behind it. They were not going in front of it. Once the camera lens is completely out of focus on a light source, all the light is out of focus. So you would have there's no way you would get a sharp line on the tether and then you would get an airy disk separate from that. And if the two fused together, you would just get a lot of blurry light. When we did the test earlier with the video cameras similar to the quality they're using on the space shuttle, in fact the cameras on the space shuttle are much better quality than the camera we did this test on, we held a pair of keys only 4 or 5 inches in front of the camera while the camera was focused on a tree 100 or 200 feet away. Both were in perfect focus. That's because the depth of field of the actual camera, if this is the camera here, the video camera here, and the light is coming into it, what is known as depth of field is when a lens focuses on an object. Say we focus on this CD right here, this compact disc right here. Basically, once we're in focus on this object on a regular camera, from that point on, you have something called depth of field. Meaning, if you focus on this point, as objects get further and further behind it, Depending on the aperture of the lens of the camera, a smaller aperture gives you greater depth of field. Objects start to fall out of focus as they get further and further away. The same thing happens when you're focused with a regular camera on something far away, like a tether. The tether was 77 miles away and drifting into 100, and then something came close to the camera, very close. It would actually just appear as a very soft blur of light, which is what an airy disk is. Depending on how bright the object was, you might get a little bit of a brighter disk. But again, these disks, and you'll see some footage of them from the space shuttle of what real airy disks look like. They're very distorted, very, very out of focus. You don't get details when a camera goes that far out of focus. Now, the video camera is very different than a normal camera. The video camera doesn't have a film plate. It has sensors called CCDs. The CCDs in modern video cameras, such as those used on the space shuttle in the 1990s, are very similar to the cameras that we did the test on, with the pair of keys and the tree in the background. With CCDs, as objects come close to the lens, while the camera is focused on a distant object, you get phenomenal depth of field, meaning the object coming close to the camera, in this case the keys were only 4 inches away from the camera, were perfectly in focus. At the same time, the tree was also in focus. So you could not possibly get an airy disk with a camera like this. You would have to turn all of the camera's light out of focus to get an airy disk. And in this case, we know the tether was in focus, and therefore anything coming near the camera should produce a very crisp image. So Claire Williams' theory in regards to airy disk didn't make sense to me.
Continuamos con la siguiente parte. Hola amigos de Factor Maya, aquí con la continuación de Evidencia, el caso de la NASA y los OVNIs.
Across the Atlantic Ocean over Africa.
The image we are seeing now shows what are true airy disks. This happens because the light reflecting off of a number of very bright objects is totally out of focus. The shuttle's cameras here are way out of focus, so we notice that we cannot make any distinctions about what we are seeing with clear features. But if we watch very closely, we can see that the space shuttle's video camera is going further and further out of focus very quickly, precisely as a large, brightly glowing object, which is pulsing, traveling on a 45-degree plane from left to top right and out of frame. Could the camera operator have intentionally moved the camera out of focus to avoid capturing this unidentified flying object as it flew by at close range to the shuttle during a live NASA broadcast? We can barely identify this amazing object so similar to the dish-shaped UFOs seen during the tether incident. In the test demonstrated, the only case this can happen using the shuttle's video cameras is when the camera lens is put far out of focus. When the video camera lens is in focus on a distant object, such as the tethered satellite 77 to 100 miles away, objects coming near the camera lens do not go out of focus. Therefore, they simply cannot produce airy disks. Also, more precisely, an airy disk cannot appear to pass behind an object 77 to 100 miles away, such as the tethered satellite, or any distance away, because they only appear when the lens is far out of focus. And when the lens is out of focus, we cannot make any distinctions about what we are seeing. Also, when you consider the number of things that look like this, in this case we have a CD, a compact disc, we all know what these are now. They look very similar, but they're not the same thing. A tire also has a hole in the middle, and it's wheel-shaped. UFOs are classically disc-shaped. This is what they normally look like. So because things look similar, we can't make the mistake of assuming that they're all the same thing because they look like they're the same thing. So anyway, in this debate, Claire Williams absolutely would not concede that what we were seeing were UFOs. But she did admit to me that she's mystified by the subject because she herself has actually seen UFOs.
A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it. Max Planck, the godfather of quantum physics.
Why would this this investigation on NASA UFOs moving into quantum physics. Because without some basic understanding of magnetism, gravity, and light integrated into quantum ideas, the next observations about the UFOs would be impossible to comprehend. We were about to study phenomena that only quantum physics could explain. On the night of January the 10th, 2000, a giant new theory in quantum physics exploded into my mind with crystal clarity. The theory would prove that gravity is grading in frequencies that eventually, at higher frequencies, would go far beyond light speed, and that those higher frequencies of gravity would conquer the vast diameter of our own galaxy, 100,000 light years, in 1 second and then in 0 time. Eventually, the theory would show how the highest frequencies of gravity could conquer the distance of the entire universe in 0 time. Thus, gravity at this highest frequency would be the only force that is truly beyond space and time. A brand new theory in quantum physics exploded into my mind with crystal clarity. The theory would prove that eventually electromagnetism and gravity waves would go far beyond the speed of light, eventually conquering the vast distances of space in 0 time. It seemed like an impossible theory. Einstein said that nothing can move faster than the speed of light. Nikola Tesla, who preceded Einstein, the inventor of the alternating current generators, radio, and over 100 other U.S. patents, said that energy waves were vibrating many times faster than the speed of light in the higher ethers, and that eventually those waves slowed down to what we now know the electromagnetic spectrum and became visible light waves. He did experiments that actually proved his hypothesis, but his theories were ignored as the world was heralding Einstein as a great genius. Einstein put the limit on us of light speed, and there was just no way in my mind I could accept the idea that extraterrestrial civilizations would travel as slow as light speed from 4.3 light years away from Earth, Alpha Centauri A and B, and Sirius A and B stars 8.7 light years from Earth. That was too long to take a trip to go find out who your neighbors were. There must be something called beyond light speed, and it must actually exist, and these UFOs must be utilizing energy technologies and propulsion systems that allow them to break the speed of light. Before I actually looked at the waves that were pulsating from the UFOs, I actually had this new theory in physics. And the theory doesn't go against traditional wave theory. It's a new way of looking at waves, in a way that is not contradictory at all to the formations of our own galaxy and our own universe. Traditionally, waves, as we saw before, were looked at on their side, and as they oscillated faster and faster and faster per second, we saw an increase in energy. It was Max Planck, the godfather of quantum physics, who said, and I quoted him earlier, that energy was equal to the frequency of the oscillation of a wave. The H really stands for 1 hertz. So 1 Hertzian wave, one oscillation of a wave represented 1 hertz. Later, the H in Planck's formula became known as Planck's constant, which became identified as a quanta of photons. But actually, Max Planck didn't really believe in photons. He believed in waves. It was Einstein who came along later criticizing Max Planck and saying that really there were photons, there were mass particles, and we discussed earlier how we went from E equals HF as the main theory in physics to E equals mc squared, mass times the speed of light squared. So today both theories are actually respected, and more people are leaning towards observations in quantum mechanics, in quantum energy. What I'm about to show you is an absolute breakthrough in wave theory. It will appear very simple as I explain it, but in the outcome, you'll see how we actually break the speed of light. I call the theory gravity beyond light speed theory because looking into the core of a galaxy, looking at a galaxy, I finally understood what was going on. If a galaxy was working perfectly and created the largest amounts of energy in existence known to science, and there must be something about the galaxy that could reveal to us how we could reach these tremendous levels of energy required to go beyond the speed of light. So looking at a galaxy, I felt I understood it for the first time. So what I did is I built what's called a galaxy clock. I'm not actually creating a galaxy, I'm creating the energy that actually created the galaxy itself, and I'm going to show you how that all works and how that relates to going beyond the speed of light. So the first thing I've done is I've used the distance that light travels per second as 1 inch on the galaxy clock. Light travels 186,282 miles every second. It's constant. It never changes. It doesn't slow down and then speed up. So because that's a constant, I can use that as a mark on my clock. So every second on each of these wheels spiraling further and further inwards, the galaxy makes in 1 second, each wheel goes one distance of the speed of light. So this distance from here to here is equal to here. So we're going to actually see the movement of electromagnetism, which is what light is, as it moves through these concentric wheels in the galaxy clock. This line here represents gravity, force, space, and time, which is actually the distance between the center of my clock and the outermost wheel in a much greater distance. And it actually represents a force called gravity that we'll actually see growing as we move through the clock. So what I'm going to do now is, as I've already counted 12 points on the galaxy clock, I'm going to connect all of the relative lines into each concentric wheel, and you're going to start to see what's actually happening in the clock.
Continuamos en la siguiente parte. Hola amigos de Factor Maya, aquí con la continuación de Evidencia, el caso de la NASA de los OVNIs.
We're going to see that second number 1, this happened. We went from this line to this line. We don't really see much change yet. In the second, connecting each line, we can start to see a little bit of a curvature happening in the second line. In the third second, we can see the clock is starting to curve. Space and time is actually starting to curve. The oscillations per second are starting to increase as we move closer to the center of the clock, as we move through time. The fourth second, we can really see things starting to change now. The fifth second, and the sixth second. So far, in 6 seconds on the galaxy clock, we've made a half an oscillation in the innermost wheel, and we've made a very insignificant amount of oscillation in the outermost wheel. So as electromagnetism starts to spiral inwards on each concentric wheel as we move inwards, we can see an increase in the oscillations of the waves. One oscillation of a wave would represent 1 hertz, or 1 hertz in the formula of Max Planck. Energy is equal to the frequency of the oscillation of a wave. So we're seeing an increase in the oscillations of waves. Therefore, we should see an increase in energy, because as wave oscillates more times per second, we'll actually see energy increasing according to Planck's formula. We saw the same thing happening in the electromagnetic spectrum. The faster waves oscillated per second, the more energy they produced. We're going to learn how that energy is produced in a moment, but let's go another 6 counts on the galaxy clock. The 7th second. The 8th second. At the 8-second point, we're actually going almost 2 times the speed of light, according to my theory. We've touched the gravity, force, space, and time line here, and in the same second we've crossed the speed of light twice. The distance that light travels per second is this distance, but we've gone through 2 of them in 1 second. So at this point in the galaxy clock, I detect that there's so much energy present that photons and mass are starting to accelerate beyond the speed of light. So here we've gone 2 times the speed of light. The 8th second. The 9th second, actually. Here we've touched the wheel, and we've gone just a little bit past 2 times the speed of light. The 10th second. All the way to here, we've almost gone 2.5 times the speed of light on the 10th second. in the innermost wheel. The 11th second. Three times the speed of light in the innermost wheel. And the 12th second. All the way to 12. So at this point, we can start to see the formation and the beginning of what looks like, at the 12 count position here, the spiral arm of a galaxy. We can actually see the beginnings of the creation of our own galaxy. Our own galaxy is created by this principle. By this theory, I'm actually showing what is actually happening in our galaxy, how energy is moving, and how creation is happening. The oscillations per second here are one oscillation per second here, and not even, if we reached here on the outermost wheel, we would be at 1/4 of an oscillation in the outermost wheel. So the theory is demonstrating that as electromagnetic energy, light, starts to spiral inwards on smaller and smaller orbits, we see an increase in the oscillations per second, and therefore an increase in energy. And as energy increases, it starts to affect particles, it starts to affect mass. Just as Dr. Earl Van Landingham said that 18 MeV protons could allow spacecraft to do 1/10 the speed of light, so as energy increases, as electromagnetic energy increases, as the oscillations increase, when that energy, when mass comes in contact with that energy, it starts to accelerate. But again, Einstein's law prohibits that solid mass can go beyond light speed. But there's another phenomenon happening in the galaxy clock. As the frequency of energy increases, so does the frequency of mass. And as mass increases in frequency, in essence it becomes lighter. It becomes less and less mass. So actually we're taking Einstein's theory in reverse. He's actually correct. Mass cannot attain the speed of light. But if mass becomes less mass, in other words, as its frequency is raised, mass is reducing. Mass is becoming lighter and lighter and lighter. And if mass can become lighter and lighter and lighter as it attains higher frequency, then mass can actually accelerate towards the speed of light. And in a moment, we're going to build phase 2 on the galaxy clock. We're going to start from here and go another 12 points and see what happens next. So now we're going to look at phase 2 of the galaxy clock. We're going to see an even further increase in the oscillation of waves as we evolve in this clock. So we last left off at the 12 count position, and we had already broke the speed of light. The frequency of electromagnetism, or gravity, the gravity force space and time line, broke the speed of light. I never changed the speed of light on the electromagnetism moving in these spirals as we moved in. On each wheel, the speed of light remained a constant. We never changed the speed of light there. What started to happen is the power and the frequency of gravity of electromagnetism represented by this line started to get so powerful that as we got near the center of the clock and we got to the 12 count position, that force became so powerful and there was so much energy in it that it started to affect mass. And mass, therefore, as it came in contact with these greater charges of energy, started to accelerate. So now we're going to go another 12 counts up to 24 and see what happens. I've already drawn the first line, the 13 line, and we can see what's happening there. And it takes us all the way to this point. So our wave is growing, and it's also curving more. So the 14th second. Connecting all the lines at the 14th count on the galaxy clock. We come to the 14th count right here. The 15th second. All the way to the 15th position. The 16th second. Connecting each point on the galaxy clock on each wheel at the 16 count position. We're starting to see what's happening. The 17th count. connecting each point on each wheel at the 17th count position to come to here. The 18th count. Connecting each point on the 18th count position. And the 19th count. At this point here, we're at least 6 times the speed of light, because in the same second, while electromagnetism is following the speed of light on the waves, the electromagnetic or gravity force space and timeline in the same second is jumping from this point all the way to here. And that represents 1, 2, 3, 4, 5, 6 times the speed of light. So it's incredible what's...
Continuamos en la siguiente parte. Hola amigos de Factor Maya, aquí con la continuación de Evidencia, el caso de la NASA y los OVNIs.
To happen here. We're starting to see the acceleration of mass going far beyond the speed of light. And one of the things that happens as photons, as any mass in this high frequency wave state starts to accelerate past the point of light, we're starting to see what's going to happen and what is representative of a black hole in the center of our galaxy. I'll explain that in a minute as we finish the clock. The 20th second. Connecting all the points the 21st second. And the 22nd second. And the 23rd second. I'm coming down to the last seconds on the clock, and the 24th. What starts to happen here is the oscillations here are increasing so much. Again, as we look at this galaxy clock, we are seeing the creation of our own galaxy. We can look now for a moment at what the core and what a galaxy actually looks like, and we can see the same phenomena happening. The same creation is actually happening. So what's actually happening is if we take this spiral into an eternally smaller and smaller and smaller orbit, what starts to happen is the oscillations per second of the wave increase so dramatically as we get into smaller and smaller micro-orbits that basically go into the millions, the billions, and the trillions, and all the way to a Google. A number that is so high that as the oscillations get smaller and smaller and smaller, there's actually no end to how small we can go, because we can go into the micro-universe. And as we go into the micro-universe, the oscillations of the wave become so high that the frequency of gravity, the energy in the vortex, the gravity, force, space, and timeline is showing us that as it's curving and as it's oscillating faster and faster and faster, that mass, as it comes in contact with this force, starts to accelerate. Photons go from a lower frequency wave state into a higher frequency wave state. For example, in the radio spectrum, as we looked at the electromagnetic spectrum earlier, the lowest part of the EM spectrum that we know, waves are oscillating at around 1,000 times per second. By the time you get into visible or even radio frequency, you're at 1 million times per second. A wave is oscillating 1 million times per second. That means over a distance of 186,282 miles, if we had a wave that long and we coiled it, it would oscillate 1 million times in the frequency